Hello again, guys. Today's video is going to be on squares and square roots. If you notice right here, I have a couple examples of perfect squares. The first one is a square that is 1 by 1. And this square, if they ask me to find the area of it, I would be doing 1 times 1, which is giving me 1. Now, this could go backwards, so if they gave me the area, if they said I have a square that has an area of 1, find the side lengths, that's where I'm working backwards, which is where we're dealing with square roots. Now, I want to focus on why they called square roots and squares. The reason they're called that is because the reason square roots came to be was based on the area of squares. So the square roots are basically the side. If a square had a certain area and they wanted you to find the side, that's where square roots were discovered. So for that first problem, the area of that first square would be 1 times 1, and therefore the side length of that square would be 1 and 1. Let's go ahead and look at that second one. So if I have a square that's a 2 by 2 and they ask me to find the area, I would be doing 2 times 2. Now, again, it could go backwards. If they told me I have a square that has an area of 4, what are the sides? You would be finding the square root of 4, which is 2. Now, do not get confused with dividing by 2. Those mean two entirely different things. And I catch students making this mistake all the time. We are not dividing by 2, but instead asking ourselves, if a square had this area, what would the side lengths have to be? If I multiply those two numbers, that would get me to that area. So for example, let's go ahead and look at the next one. We have a square that's a 3 by 3. If they asked me to find the area of the square, I would be doing 3 times 3. Now again, if they worked backward, if they said, I have a square that has an area of 9, what are the sides? You would have to find the square root of 9. So you have to ask yourself, what number times itself would get me to 9? And the only number that works is 3, because 3 times 3 gives me 9. Okay, same thing goes for this one, guys. Let's start with the working backwards part here. Here they're telling me I have a square that has an area of 16. If I want to know the side lengths, I need to ask myself, what number times itself is going to give me 16? And the only number that works is 4, because 4 times 4 gives me 16, and I can prove it by that picture. Okay, let's do the same thing with that last one. Let's do it working backwards. So if I have an area of 25 and I'm working backwards to find the side length of this square, I'm actually trying to find what number times itself gives me 25. Now again, remember, we are not dividing by 2, because if I divided by 2, that would give me 12.5, and that's not what I want. I want to know what number times itself gives me 25. The only number that works is 5, because 5 times 5 gives me 25. The next thing I want you to write down is, I want you to copy down this list of perfect squares. These perfect squares are going to be very, very useful, especially when you enter 8th grade, you'll be expected to be able to estimate square roots. We don't focus that much on that as 7th grade, but it is important for you to understand the concept. So please go ahead and copy these down, and I will show you in the next step why are these important to us. Okay, so in this following slide, I have shown you how do we estimate perfect square roots? So let's say, guys, that they told me that there's a square that has an area of 18. Well, if you're trying to find what number times itself gives you 18, we don't have any because it's not one of those perfect squares of 1 times 1, 2 times 2, 3 times 3, 4 times 4. So what I want you to notice something. I know sometimes it's hard to memorize these, so there's a pattern, and that's what I wanted to touch upon real quick. Let's real quick glance at the other perfect square list that you had. If you notice, there's a pattern happening here. From 1 to 4, I went up by 3. From 4 to 9, I went up by 5. From 9 to 6, I went up by 7. So what pattern are you noticing? Every time I'm adding 2 more. So I'm adding 9. So if you were taking the STAR test and you forgot what are the perfect squares, you can easily make this list, guys, if all you have to do is just continue to add. And this works for all the way through. So I just wanted to show you that real quick. And this also brings us to how do we estimate? Okay, so for example, area of 18. Remember, since the area of the square is 18, we're actually trying to find the square root of 18. Okay, on this number line, guys, they're showing you the squares on top, and then the second number is showing you what number times itself gives you that square. So right now, 18 is right here. But if you notice, there is no number times itself that gives you that. But I can estimate it because look, I have 2 perfect squares. I have 4 squared. I'm just going to write it bigger for you to be able to see. And 5 squared. And in between there falls 18 right here. So there's a total of 9 spaces between 4 squared, which is 16, and 5 squared, which is 25. So what I want you to ask yourselves is 18 closer to 16 or closer to 25? And if I was to ask you to put this on the number line, where would you put it? Well, the good thing is for this one, it's already placed on here. But if I was to estimate on this number line, between 4 and 5, we have this point. So if I asked you to tell me some sort of decimal, you should be able to tell me it's about 4.3. Because remember, here is 4, because 4 squared gives me 16, and here is 5. 18 is about right here. Therefore, if I was to actually enter it into a calculator, I would get about 4.3. And now I wanted to look at what kind of problems would you expect on the previous tax test, now STAR test. And here's one. It says the model below shows the square root of 49, which is 7. Which arrangement of small squares can be used to model a large square that represents the square root of 196? So basically, they want to know what times what would get you to 196. So let's go ahead and look at the answer choices. We already can eliminate A and B. Why? Because, guys, we're dealing with the square. Square roots and perfect squares all deal with squares. And a square has to have the same length and the same width. Always, always, always. In this case, they're showing you 4 rows of 49 squares. That's not going to work because that would be giving you a rectangle, not a square. So right now I'm left between 12 rows of 12 or 14 rows of 14 squared. So if I'm trying to find the square root of 196, I want to know what number times itself gives me it. So if I do 12 times 12, and if I don't remember, I could use my chart that gives me 144. So I know it can't be that one. And if I do 14 times 14, I get my correct answer. So that would be my final answer. And that's it, guys, for squares and square roots. If you have any questions, again, after the video, please ask me anything that you might still be confused on, and then continue with the activity.